All right, so here we have an introduction to control charts. It sounds scary. Control charts sounds scary. A lot of math involved. Well, it's not that much math and it's not that scary. In fact, it will kind of change the way you look at most anything. The key concepts here are that no two products are exactly the same. Is that true? Well, maybe they could get lucky, but there's so many variables involved in a item. Let's look at this. No two products are exactly the same. Every time you buy a Coke from now on, a soda from now on, notice, is the bottle filled to the exact level every time? Well, these bottles are supposed to have 500 milliliters of liquid in the bottle. How many times is it actually 150 milliliters? Will it be 498? Will it be 502? We saw this with the toilet paper experience. We have variation, and the goal is to know what your system is capable of and know how much variation there is that's inherent in your processes, and we want to reduce variation. That is important because and you've seen this, if the soda bottle is filled all the way to the top or maybe down to here, and I've seen that, that really damages your brand because it's not consistent. If you can't get the right amount of liquid into the bottle, I mean, how would you expect them to know the recipe, really? So now some variation is going to be there, and sometimes people don't notice. But our goal is to get variation reduced as much as possible. So we have the causes of variation. Well, this whole system has inherent variation. It can be due to materials, the machines, processes, employees, even the weather. On a humid day, the bread's not going to rise right? So you might put an AC in your bakery or a dehydrator, whatever you call it, dehumidifier in there to get consistency so your bread acts right every time. So now, we could even put management style in here because that messes with people's heads. Now, right here, what causes variation? Look at that and think of your burgers. Are your burgers going to be the same every time? Will the meat always be the same amount of weight? We hope it's close. Will there always be 3 pickles on there? We hope. Will the pickles be the same size? I doubt it. What about getting the right amount of mustard or mayonnaise on the burger? Will that be the same every time? You'll try. You notice the guns in the video for the ketchup and the mustard, an attempt to be more consistent. Will the bun be toasted the same every time? See, there's a lot of factors, and companies spend a ton of money trying to reduce this variation because people expect consistency. If you're going to order one kind of burger, you expect that burger to be the burger, not somebody's version of the burger. So, 2 concepts here. We have 2 types of variation. We have common causes of variation, which are purely random, unidentifiable sources of variation that are unavoidable with the current process. Now, that's number 1. And number 2, special or assignable causes of variation. Any causes of variation that can be identified and eliminated. Now, hold that thought. We can take, say, the measurements for the toilet paper, and we're going to do this in the next video, and build a control chart using formulas that were created by very smart people a long time ago. I think the chart says 1950. By the way, do not use your current textbook because I believe it's wrong. But we can build a control chart, and we're going to show you how to do that. But once a control chart has an upper control limit, a center line, and a lower control limit. So when we chart out the, find our upper and lower control limits, and then chart our measurements on that chart, everything that goes in here, that falls in here, would be random variation. If it falls outside of the upper control limit or outside the lower control limit, something has happened. Now, this is assuming that your system is in control. Now, if this was your, say you were making burger patties, your target is a 1/4 pound of meat. Would the machine always put a 1/4 pound in there? Well, we hope it gets close. Would the employee always end up with a 1/4 pound? Even if we measured it on a scale, you know, the scale could even kind of steer us wrong. Or maybe we have one of those weight scales with this thing and it's, you know, the needle doesn't really fall in the same spot, which is now why we have a digital scale. But let's say you hire you guys to make the burger. We could chart that out and the chart would look something like this. But what if we went and got a bunch of monkeys, or let's say 3rd graders? We went and got infant 2 students. Would their burgers be a 1/4 pound, plus or minus, like this? Or would the 1/4 pound hopefully be here, and then we'd have, boy, it might be huge, the variation. That could be huge. And then we introduce some new machines, some weight machines, train the people, get people to care and pay attention to what they're doing. We might end up with a control chart that's very narrow, closer to target and less variation. So, we need to build these control charts to find out what the system is kind of capable of and see how we do. If we fall outside or inside. If we fall outside, we're out of control, something happened. If we're in here, it's expected random variation. Common causes of variation, purely random. Okay, so when we do variables such as weight, length, volume, or time that can be measured, we can use, and there's 1,000, it seems like 1,000 control charts out there. We can use an X bar and R control charts to see how well we're doing. So we have variation, we want to reduce it as much as possible, have consistency and quality, and we have 2 causes, random and oh boy, something happened. And these get confused. So now if we build the control chart, we won't get as confused. We won't react to purely random variation. We'll only, or hopefully more often, just react to special causes when something happened. I'll give you a little example right here too. Let's say I have to make a A. You know, I'm the employee, I get paid to make A's, capital A's. And is that a good A? Ah. Okay. I don't think anything's happened, but we could measure those and put them into a control chart. What if my boss made me write like this? The system only allowed me to write like this. Oops, I've already, uh-oh. But the system, that's what we're capable of. That's now, what if somebody came behind me and pushed me? And go, well, see, now we got something, you know. But when is it out of control is the question. Boy, I would look into that and I would look into that. So, now, we'll go on and try to build a control chart.